In this video, we'll remind you of one of the main interpretations of the derivative. That is, it's the slope of a tangent line at a point. So, generally speaking, just as a reminder, if we were to start off with a curve, say y equals f of x, and at a value x equals a, if we would like to draw the tangent line there, that would be the line which intersects the curve at that point a comma f of a, and the slope of the tangent line is the value of the derivative at that point. So thinking point slope form of a line, the tangent line at x equals a has slope f prime a, and it passes through that point a comma f of a. So f prime a, x minus a, plus f of a. So up to our example. Find the equation of the tangent line to y equals 1 over x at x equals 1. So essentially we can write down kind of the template and have a few values that we need to fill in. So the equation of this tangent line, so TL for tangent line, is y equals, and I'm going to let f of x equals 1 over x for simplicity, will be f prime 1 x minus 1 plus f of 1. So if we can fill in those two unknown values, f prime 1, the slope, f1, that would give us the equation of the tangent line. So immediately, we see f of 1 is 1. So y equals some number yet to be determined. And then we have plus 1. So for f prime 1, we know using the power rule, 1 over x is really x to the minus 1. So the minus 1 comes down, the new power is x to the minus 2. So the derivative of 1 over x is minus 1 over x squared. So f prime 1 is minus 1 over 1 squared, which is minus 1. And if we simplify this just a smidge, think of that minus 1 distributing through, we'll have minus x plus 1 plus 1, which gives us the equation of the tangent line to the curve y equals 1 over x at x equals 1. So very similar problem. So once again, I'm going to think of my function f of x as being the given equation, sine of x, and I'd like to find the equation of the tangent line at x equals pi. So down at the bottom, I'm going to write out my template. Y equals f prime of pi, x minus pi, plus f of pi. And once again, I just need to determine two values here. What is the derivative f prime pi? What is the function value, f of pi? So taking care of the function value first, f of pi is sine of pi. And one thing we should be very efficient with is values of the trig functions at those common angles. So think 0, pi over 6, pi over 4, pi over 3, pi over 2 multiples. So sine of pi is 0, so we get sine of 0, which is also 0. Now we need f prime so that we can figure out f prime of pi. So to find f prime, we have a composition, sine of sine. So we take the derivative of the outside function, evaluate at the inside function, and we multiply it by the derivative of the inside function. So the derivative, f prime, is cosine of sine multiplied by cosine. So f prime of pi, replace those two x's with pi's, cosine of the sine of pi times cosine pi. So as we mentioned, sine of pi is 0, cosine of pi is minus 1, and cosine of 0 is 1. So 1 times minus 1 is minus 1. So our slope of our tangent line is minus 1, and f of pi we calculated above to be 0. So written equivalently, we have y equals minus x plus pi. So remember the interpretation of the derivative. The value of the derivative at a point is the slope of the tangent line going through the graph of the function at that point.